Hello and welcome. Today, we're going to talk about something that is absolutely critical, but honestly often gets overlooked: the security of the pre-trained AI models that your teams are pulling down from the internet every single day. So let's jump right in. I want you to really think about this for a second. Every time one of your developers goes to a site like Hugging Face or GitHub and downloads a model, they're introducing a new, unchecked dependency straight into your environment. And what's so scary is that this convenience creates this massive, almost completely invisible new attack surface, one that your traditional security tools just weren't built to see. And this quote, it just nails the core of the problem. We have this habit of treating AI models like they're just simple data files, but they are not. They are complex, executable dependencies. You would never let your developers download and run unsigned executables from some random website, right? Of course not. But we're essentially doing exactly that with AI models. It is long past time for a major shift in how we think about their security. Yeah, so that's the paradigm shift we need. Our old security assumptions just completely fall apart here. And that's because model files are, for all intents and purposes, a black box. You can't just pop open the hood and read the source code to see what it's going to do. This unique challenge makes this whole problem incredibly urgent for security leaders to get a handle on, and fast. And this slide really just lays the gap bare. I mean, look at this. For traditional software, we've built up decades of security infrastructure. We've got code signing to verify the author, we have robust vulnerability scanners, curated app stores, the whole shebang. And for AI models, we have, well, almost none of that. It's truly the Wild West out there, and we are deploying these assets directly into our most critical business applications. So let's make this threat really concrete. The number one technical vulnerability you need to know about is called Pickle deserialization. Now, Pickle is a super common format for saving Python objects, and that includes AI models. But here's the kicker: it was never, ever designed to be secure. An attacker can craft a malicious model file that, the very moment you load it, executes any code they want on your machine. And just like that, your model isn't just a model anymore. It's a Trojan horse. It's a malware delivery system. And this is the business risk that should keep you up at night. A single compromised model, downloaded by just one developer, can waltz right past your firewalls and all your perimeter defenses. It gets pulled into your central model registry. And from there, it gets deployed across maybe dozens of applications, silently infecting every single thing it touches. The potential blast radius is just enormous. Okay, so how exactly are attackers pulling this off? Well, they're essentially following a supply chain playbook. There are multiple points of attack, and a lot of these are actually cataloged in frameworks you might know, like MITRE Atlas. What's important to realize is that an attacker doesn't even have to target you directly. They can compromise a model repository, poisoning a really popular model right at the source. Or they could intercept a download in transit. They could tamper with a model you already have sitting in storage. Or they can poison a model during the fine-tuning process. Every single step in that chain is a potential point of failure. And the techniques they use are pretty sophisticated. You've got backdoor injection, which creates these hidden triggers. The model seems to work perfectly until it sees one specific input, and then, boom, it does the attacker's bidding. We've already talked about malicious code execution using Pickle. Weight modification can subtly degrade your model's performance or sneak in biases. And fine-tuning attacks are really sneaky. That's where they release a compromised version of a popular model, hoping to ride on its good reputation. Okay, that's enough about the problem. Let's pivot to the solution. And there is good news here. We can defend against this stuff. It just requires a really structured, multi-layered approach to managing your model's supply chain risk. And here is that framework. It's 4 distinct layers that all work together. We're going to start with governance, to control what even comes in the door. Then we move to verification, to inspect what you've got. After that, isolation, to contain any potential damage. And finally, monitoring, to keep an eye on it once it's in production. Let's break each of these down. So layer 1 is all about policy. It's about setting the rules of the road. You need to establish approved source lists. You just can't allow every model from anywhere on the internet. You also need a formal approval process for acquiring new models from new sources. And this one is crucial. You've got to implement version pinning. That just means you know the exact version of a model that's running in production at all times, no surprises. Now for layer 2. This is where the technical checks and balances come in. First, automate hash verification. This just makes sure the file you downloaded is exactly the one the publisher intended. Second, and this is non-negotiable, you have to integrate Pickle scanning directly into your CI/CD pipeline. This will automatically check for malicious code. And finally, you should be running behavioral tests against known benchmarks to spot any weird, unexpected performance issues. Okay, for layer 3, we're going to operate under the assumption that a breach is possible, so we work to contain the potential damage. Always, and I mean always, load and test new models in an isolated sandbox environment, totally separate from your production systems. When you do deploy, make sure you're running the inference process inside a container with the absolute minimum privileges it needs to function. That way, if a compromised model does execute code, you've severely limited its blast radius. And finally, layer 4. Security is never a set-it-and-forget-it thing, right? It's a continuous process. Once a model is in production, you need to establish its behavioral baseline. How does it normally perform? Then you set up alerts for any significant deviation from that baseline. A sudden drop in accuracy, a weird shift in its output, that could be your first sign that something is very wrong. Okay, so that's the 4-layer strategy. Now let's get really practical and turn this strategy into action. You can start with a simple checklist like this. Ask these questions. Is the model cryptographically signed by the vendor? Is it hosted in an official repository, or is it on some random third-party account? Is there clear documentation? Look, a model from an anonymous user with no signature is high risk, plain and simple. Your policies need to reflect that. And here it is. This might be the single most impactful technical change you can make. The SafeTensors format. It was designed specifically to solve this whole Pickle problem. It physically cannot execute arbitrary code. By standardizing on SafeTensors wherever you possibly can, you eliminate an entire class of attacks with one single decision. That's a huge win. We also really need to tackle some dangerous misconceptions that are floating around. The idea that a popular model is automatically a safe model, that is just false. In fact, popularity makes it a bigger target. And, as we've seen, the idea that model files can't run code is just dangerously wrong. These kinds of assumptions create massive blind spots in your security posture. So let's start to bring this all together. Everything we've talked about, the risks, the attacks, the defenses, it all really boils down to adopting a new supply chain mindset for AI. So here are the key things I want you to walk away with. Look, if you remember anything from our time today, remember these things. 1. Treat models like executable software, not like simple data. 2. The Pickle deserialization threat is very real, and it's happening now. Always prefer safer formats like SafeTensors. And finally, number 3, an effective defense isn't one thing. It requires a multi-layered approach that combines governance, verification, isolation, and monitoring. So I'll just leave you with this question to take back to your teams. Right now, this very moment, how confident are you, really, in the integrity of every single pre-trained model that's running in your production environment? If the answer isn't 100%, then it's time to get to work. Thanks for your time.